Hello and welcome to CSAC 328 and ITA 225, which is the probability and statistics. So before I introduce to you what is probability and statistics, I will discuss first the syllabus. This will be our guide for the whole semester. So for course code, we have CSAC 328 and ITA 5 with the course title Probability Statistics in Computer Science and Probability and Statistics in Information Technology for ITA 25. So the course description of this course is this course will provide you an introduction to probability statistics and its applications in many situations, particularly when designing hardware and software systems. It is extremely difficult to predict exactly how a system will behave. It is therefore essential to model such uncertainty in a sensible way so that one can properly assess the system's performance. In terms of probability, we'll discuss probability theory comprising the first part of the course. It will equip you with powerful tools to do this in a sound and effective manner. The second part of this course covers both the theory and practice of statistics. Statistics concerns what can be learned from data and comprises a body of methods for data collection and analysis across the whole range of science, encompassing areas as diverse as engineering, medicine, business, and law. Students will learn how to perform elementary statistical analysis of real data and the theory behind this methodology. This subject is a 3-unit subject. We'll have a 3 hours lecture per week. And the prerequisite for CS is CSAC 111, Calculus for Computer Science. For your learning outcomes, so we have 2 learning outcomes. This will be your project. For LO1, a computer program. So a computer program simulating one topic in probability and statistics that will evaluate the students' understanding on specific concepts, combining it with their knowledge in computer programming. This will be given by phases which will represent projects for prelim, midterms, and finals. So for computer program, we'll divide it in 2 phases. So we have prelim, midterm, and final. So let's say for instance for prelim, your project will be data collection or finding a data set for your computer program. The second project is LO2 documentation. So this will be submitted in the final. So this is a documentation of the computer program with a detailed explanation. For other requirements and assessment activities, so we have the problem set. So after every topic, a problem set will be given to you. It's either in a form of coding or problem solving. We also have quizzes. So this is a quick check short assessment which may be conducted after the discussion of every topic. This shall be given in a form of real-time quiz via CSPC Leon. You will have also prelim, midterm, and final examination. So this comes in a form of a major written examination or problem set submission or compilation of. For our grading system, so 50% is class standing. Class standing consists of quiz scores, problem set scores, and project rubric. For examination, that's also 50%. So we have prelim, midterm, and final exam scores. So if you fail to pass the examination, I will give a remedial examination for you if you're willing to take the remedial examination. Please remember that the grading system is different. So class standing is 50%, examination is 50%. So that means if you are low in examination as well as in class standing, that means there's a tendency that you will fail the course. So the computation of prelim grade and midterm grade is class standing. 50% plus examination 50%, which a total of 100%. So the computation for midterm grade is final midterm grade is equals to prelim grade plus midterm grade. This midterm grade will be calculated also the same formula as the prelim grade, divided by 2. For the computation for final grade, which will be called as final grade, we'll have the final midterm grade multiplied it by 2, add the final grade, which this final grade will follow this formula also, and then divide by 3. In short, your grade for a final grade is an average of prelim, midterm, and final grade. So in order to pass the subject, the student must obtain at least 75% as equivalent grade. For our learning plan, so this will be our learning plan. For week 1 to 6, I will introduce to you the probability. Under probability, we have introduction, counting, and sets, probability basics, conditional probability-based theorem, discrete random variables, expectation. We have also variance, continuous random variables, gallery of continuous variables, histograms, expectation, variance, law of large number, and central limit theorem. We'll also discuss joint distributions, independence, covariance, and correlation. So that's for week 1 to 6. For week 4 to 6, we'll discuss statistics. We'll discuss the first school of statistics, which is Bayesian inference. So later on, I will introduce to you the 2 schools of statistics, the Bayesian inference and the frequentist inference. Under the first school of statistics, we have the Bayesian inference. It will include the topics Introduction to the Statistics, Maximum Likelihood Estimates, Bayesian updating with known discrete priors, Bayesian updating, probabilistic prediction, odds, Bayesian updating, continuous prior, and discrete data, beta distributions, continuous data, conjugate priors, choosing priors, and probability intervals. Next will be the statistics, second school of statistics, frequentist inference, or also known as NHST or null hypothesis significance testing. Under this topic, we'll discuss frequentist methods or NHST, NHST2, which consists of significance, level, power, t-tests, NHS3, which consists of the gallery of tests, and lastly, comparison of Bayesian and frequentist inference. The last topic we will discuss under statistics is confidence intervals and regression. So if you want to have a references for this course, I have provided 10 references. For classroom policies, so you need to take and pass all long, short resets, machine problems, prelim, midterm, and final examinations, and subject requirements or project. The students are required to submit the assignment, project, case study, etc. within the date specified. Deliverable dates are not flexible. Students are expected to attend regularly and punctually all scheduled classes. However, you can, if you're having trouble or difficulties on your internet connection, you can just take the asynchronous class that I will upload on Beyond. Okay? So, you need to observe honesty and independence during recitation, examination, quizzes, as well as projects. So, any student caught to be dishonest will be dealt with accordingly based on the college policies. Students are subject to the academic integrity and behavioral expectation of the school. So this will no longer, I will update it. I will remove some of the unnecessary classroom policies. And lastly, keep your microphone on mute or raise hand in case you want to speak or participate whenever we are conducting synchronous classes. So that will be all for our syllabus. So if you have any question, you can raise it to me. I will post where you can ask question. regarding this subject.